Okay, we're on the back now. Actually, number 6, we're going to skip this. This is inverse variation. It's kind of an interesting problem where with certain mammals, most mammals they say, the heart rates are beats inversely to the lifespan. So the faster your heart rate is, the shorter your lifespan is. If you were to multiply these out for each animal, you would get approximately the same constant. They'd be very close to each other. So we're not going to do the problem, but it's kind of interesting if you're interested in doing it. All right, let's move down to part 3 here, which is joint variation. What joint does, if you do something jointly, you do it together. Joint variation is a combination of direct and inverse. What it looks like is y divided by x times z equals the constant. Joint variation is something you would do if you have 3 different variables. Direct variation is 2 variables, x and y. Inverse is 2 variables, x and y. Joint variation has a 3rd variable here, z. So we'll do a couple examples. Let's look at 7. Suppose y varies jointly as x and z. So what that means is that we're going to set it up as y over xz. Find y when x equals 5 and z equals 3. Okay, we don't know the y. X is 5 times z is 3. If y equals 18 when x is 3 and z is 5. Now what you'll notice in this example is that actually both of these denominators are going to be the same. You get y over 15 equals 18 over 15. So in this problem, it's pretty easy to solve because if they both have the same denominator, if 2 fractions are equal, if they have the same denominator, they have to have the same numerator. So you know that y is equal to 18. But if we wanted to cross multiply, we would get 15y is equal to 15 times 18, which is going to be 270. And 270 divided by 15 is equal to 18. Okay, so there's number 7. Let's do a problem where it's going to be a little bit different. So check out number 8. Suppose y varies jointly as x and z. Find y when x is 5 and z is 27. If y equals 480 when x is 9 and z is 20. So what I'm doing, I'm setting up 2 fractions. The first situation, I'm putting the numbers that they give me. Find y, we don't know that. X is 5, z is 27. So they all go together. And the second situation is the other fraction. Y is 480 when x is 9 and z is 20. So what we'll do here, let's work out the denominators. Y over, that's 135, equals 480 divided by 9 times 20 is 180. You can reduce the fraction first if you want to. I'll just cross multiply. So we'll get y times 180, which is, let me come up here, 180y equals 135 times 480. Now I'm going to let the calculator do the work. 135 times 480 equals 64,800. Okay, 64,800. Now I'm solving for y, so I'm going to divide that by 180. So we'll take that, divide by 180, and the solution is 360. So y equals 360. And there's the solution. All right, so let's finish off here with 2 problems. These are both word problems. Number 9, the volume of a cylinder varies jointly as its height and square of its radius. All right, so here's how we're setting this up. Volume varies jointly as the height and the square of the radius. The square of the radius would be r squared, r to the 2nd power. I multiply the variables in the bottom. What is the constant of variation? If the cylinder has a volume of 141.37 cubic inches, that's my V, when the height is 5 inches and the radius is 3 inches. So 5 times radius squared equals the constant of variation. They're not actually asking me to solve for a variable. They want the constant of variation, so I'm going to set it up as y over x times z equals k. Now, in the denominator, 5 times 3 squared, that's 5 times 9, which is 45. So what we get here, 141.37 divided by 45 equals k. Now, when we go to the calculator and we type this in, 141.37 divided by 45 equals, now look at that, 3.1415 repeating. Basically, this is pi. You get 3.14. The constant of variation is pi. And if you're familiar with the equation for the volume of a cylinder, this is just off on the side. Volume of a cylinder is 1/3 pi r squared times h. Pi is the constant of variation. So that's kind of interesting how that works out. And that makes sense because the formula has pi in it. So there you go. The constant of variation is pi. All right, we'll do one more here. Sorry, volume of a cylinder. Nope, not 1/3. It's just pi r squared h. I was thinking of a cone. So pi r squared h, now that makes sense. So 3.14 r squared h. Sorry about that. All right, the last one, number 10. Kinetic energy varies jointly as the mass and the square of the velocity. Mass, square of velocity. So kinetic energy, I'll use a K, well, I don't want to use K. KE, kinetic energy, varies jointly as mass times velocity squared, the square of the velocity. That's how we're going to set it up. A mass of 8 grams and a velocity of 5 centimeters per second has a kinetic energy of 100 ergs. So the kinetic energy of 100 ergs when the mass is 8, so m is 8, and the velocity is 5, so 5 squared. Find the kinetic energy for a mass of 6 grams. So the mass is 6. The velocity is 9 centimeters per second, so that's times 9 squared. So there's the kinetic energy, that's our variable in this case. So we're going to solve this. Let's go ahead and work this out a little bit. 8 times 5 squared, that's 8 times 25. 8 times 25 is 200. So we have 100 over 200 equals the kinetic energy divided by 6 times 9 squared is 6 times 81, which is 486. Now I'm going to cross multiply, but I can make life a little bit easier by first reducing a fraction. 100 divided by 200, it's the same thing as 1/2. So if I make that 1/2, now when I cross multiply, I get 2 times the kinetic energy equals 1 times 486. Divide by 2, and the kinetic energy equals 243. And that would be ergs, 243 ergs. All right, that is it for the notes. Again, I apologize about the volume for the cylinder. It is pi r squared h, not 1/3.